Welcome to the Digital Amateur Television Experimenters Night. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night and VK7 Tango Whiskey at the mic for tonight's episode. And we are absolutely cram-packed tonight with bits and pieces, and I'll ask Murray ZMS and Richard VK7ZBX to make their way to the studio. If they're out there listening, there seems to be a lot of talking going on out in the club room. So there's good evening from Anthony VK7LAG, the new call sign. So congratulations, Anthony, on your new call sign. Good stuff. Just a reminder, you can call in and make comments on the YouTube chat channel. You've also can call in on repeater 2. 146 700, and also DMR talk group 3807 is another way that you can get to us. So there you go. So what I just thought I would do is one of the things that came to my attention during the week is now if I do that and that. Bit of a sneak preview of the possibly the next cover of Amateur Radio magazine. I think this is this is number 4 for 2020 that is currently being worked on, and there is a suspicious-looking backpack there with a suspicious-looking 705 IC705. With a suspicious call sign on the backpack, up on a cloudy Mount Wellington, and there is a interesting pair of legs there with Priscilla's Portable Pleasures or Portable Pleasures. So that's a bit of a sneak preview to our next AR magazine cover potentially. So I just thought I'd share that with you, and we'll see where that goes. Now I'll just go and grab Murray and Richard and we'll start on our review of the RD contest results. So just stand by. All right, we'll grab Murray and hello, Murray.
Good evening.
Now, if I go to a slightly wider angled camera, which will be not that one, but that one, and
Correct.
let's move to that one. Ooh, there we go.
Scary dudes.
That's now, and we'll go to there we go. Now we're on the screen, so that's what we're actually seeing. You'll see up there. And I welcome Murray VK7ZMS and Richard VK7ZBX to the studio. Now, my first thing is congratulations.
Thank you.
It's almost like a bit of a podium, isn't it?
Well, we should be sitting slightly. You should be here, and I should be there, and Richard should be there. So, Murray is, of course, the winner of the single operator phone section with a humongous score.
We are, of course, talking about the Remembrance Day contest.
Correct. So, the very first thing I thought I'd say, apart from congratulating Murray and Richard, was we, as in VK7, took it out for the 5th time, and 20% of VK7 amateurs participated, and 70% of them put in logs, which was 51 logs. So that you got to be happy with that. Absolutely got to be happy with that. That is just a phenomenal participation rate, and I'll show that in the report in a moment. So Murray came first in the single operator. I came second, and Richard, 2 points behind me, came third.
No comment.
Can I just say Ben with 303 points came third in the single operator QRP section. Peter VK7 KPC up north came second in the single operator QRP mixed section with 40 points. And there were only 2 entries in that particular section of the RD. And Anthony VK7FBOC, who is now, and he actually happens to be on our chat channel, who is now VK7LAG because he has upgraded to his standard. So congratulations on that, Anthony. Came third in the foundation section with 253 points. And also, now the 2 people who are here on screen are 2 of the members of the Cronies +1. In fact, we've got the Cronies.
And the
Because
+1 is
that's
not
right.
here tonight.
And the +1's not here, which is Hayden. So, and the points that they came in with the with the team entry was a record-breaking 2,937 points. So that 3,000 points is just in your
Elusive,
sights.
yes.
Just in your sights. So congratulations.
Thank you.
That is fantastic. And it just blows, I think, everybody away. So if you have a look at the points right back to 2012, which the report, I encourage people to have a look at the Remembrance Day contest report on the WA website. If you have a look at that report, it has right back to 2012 of a whole range of different scores, so you can do a bit of a comparison. But what I thought I would do was this is the telling chart. Let's go to there and zoom in a bit here. Now, this particular chart, and I'll just try and make that a little bit better. Okay, I'll maybe not make that terribly much better. This is the VK7 score. The logged contacts, 9,887. The phone is a vast majority of that, and 117 of them are the CW. The raw score for those are 13,679. The weighting factor was 246, but the weighted score, if you have a look down here, VK1's 2%, it's 1.5%, it's 1.7, it's 1.26, it's 3.6. For VK6, which is the closest that we got, that a state got, was 5.7. VK7 was 55.61. VK8 was 0.31, etc., etc. So that was just a very telling, very telling little table there. Now, the other thing I'd just like to point out, apart from this is the overall scores. The huge number of VK7s, and you can see that's the 51 logs that were put in across all of the categories. So just over the top. The phone contacts per state. That's also an interesting chart. The one here in the middle. Have a look at across the bands, so from 160 metres all the way to greater than 3.4, which is the bottom scale here, the bottom table line row here. If you have a look at the other states, mainly HF.
Scores or?
HF, this is score. This is phone contacts per band per state. So this is contacts.
Yep.
This is contacts.
Contacts, yep.
This is contacts, not scores. But VK3, there is a smattering across all the way up to 1.2 gigs. VK4, it's all HF and some 1.2 gigs. VK5, there's a smattering, mostly HF, all the way up to 1.2. VK6, this was our competition, if you like. All the way up, and lots in the 144 and 70 centimetre 1.2 gig up to 1.2 gig. VK7, lots in the HF, but lots in the 144, so 2 metres, 70 centimetres and 1.2 gig.
871 contacts on
1.2 gig, so 23 centimetres. So this and a fair few of them were in that sweet period between.
I would have thought we would have had more than 11 contacts on 3.5 and above.
No, because that's basically 10 gig.
10 gigs. That was.
Did you operate 3 gig?
No, we didn't do 3.
You did 2.4. You did 2.4.
But there was 4 operators on 11 on 10 gigs. That's only 3 contacts each. I know I did more than 3 contacts on that.
Okay, good question. Very good question. Now, I just thought it'd go. The report's actually worth a bit of a look because it includes the error log. So this is where we all go bugger. Now this is probably not going to show very. No, I'm not even going to go there. Let's go back to our people and yeah, Warren. I just that's good.
I don't think we're in the right.
Yeah, sorry. We'll get it up there. So that's good. We're on that camera there. We are on that camera. Yes, we are. And we can zoom to us. So just do a little bit of tricky stuff there. So
Tricky stuff. It'd be
now
better to have the person talking.
on the television.
Yes.
Okay.
In
You want to do that?
my humble opinion.
All right. So on the error report, I highlighted the top 3 places of the single operator phone section. Oh, now, actually, before I do that,
Explain the error log first.
okay, the error log, which is rather large, the error log is where the system, so the logging system, has picked up where it's been able to match a call because of time and one or other of the call signs, but there's an issue. So the other person's got the call sign wrong, or they've logged the wrong band or the wrong mode, or and there's a few examples that I'll go through. So this is all done automatically. But the interesting thing is, before the error log, there's a little section in the report which lists the golden logs.
What are golden logs?
The golden logs are logs that were submitted that did not have any errors.
Oh, right.
I'm going with not many of those.
So, now I'll just find the golden logs.
What's in this report? Is it on the site? Or?
Yeah.
It's on the
It's on the WA website. Where is it?
So golden log is the
Hang
complete
on,
log
a
of
golden
the
log.
station.
Without a
That,
single error.
Without a
Didn't have a
single
single
error.
error.
It didn't have a single error.
Oh,
Here we go.
golden logs.
Here we go. Golden logs. So I can show this on here because so this is the golden logs. So there were 43 golden logs, i.e. no errors, and these operators had a score of 50 or above without any unique call signs therein. So, and I just highlighted there are 3 there, which is Andrew, Scott and Alan. Alan, who is out there. So Alan, if you're listening, you're one of the golden log entries. In fact, you're the highest scored golden log entry. So with 492 points.
Okay.
So go and get him. Go and get him. So this is the golden logs have absolutely nothing actually wrong with them.
But somebody else could have a golden log, but the contact that they made might have an error, in which case they'd be discounted as well.
Correct. And I'll actually show you that because there's some examples in our 3. Congratulations, Alan.
I may not deign to talk to you lower lifes.
Oh, okay, yeah, because the holder of the golden log. So I just point out here, if you have a look on the screen, Alan,
Yes.
492 points. So you're the highest scored golden log, which means you've got the most contacts that you didn't get wrong.
Correct. Good, isn't it?
So that's pretty impressive.
I don't understand. And I did it by pen and paper.
Even more impressive. So, because that could introduce transcription errors.
Yes, it could.
Okay.
So is the definition of a golden log a log that has no unique call signs?
And a few other things.
Without any call signs and no issues. So,
No errors and no unique call signs. So a unique call sign indicates an error.
Not necessarily.
Yes, if it's a unique call sign, it's not mentioned anywhere else in anybody else's log.
Yeah.
You've made a mistake.
yeah.
Or
They didn't put in
put
a
in
log.
They didn't put in a log.
Yeah.
What if you've got
And
less
didn't
than
contact
50?
anybody else?
Less than 50 score. Because it says there are a total of
Yeah.
43.
Yeah.
There's
Are those
possibly
other
others.
ones?
There's,
Yeah.
there's,
listed somewhere?
there's possibly others. So they only list the ones that had a score of 50 or above.
Yeah.
Yeah. So you could have a golden log, Warren. You could be vying for position with Alan.
Well,
Yeah.
if you go through the other big long list, you'll find out.
Yeah. Now, good point.
And I really wanted the extra 8 points, but I just couldn't do it in the last few minutes.
Dear, oh dear. Okay.
Next
now,
year.
Lots of us were trying for those extra 8 points at the end.
Next year. That's it. Okay. That's now. Let's go to here. So the golden logs. Let's go to the error log. Now, I'll give you a good example where I got it wrong, but the other person didn't. So I had 2 issues with my logs. VK7TW to VK7GN, so Martin, no matching contact found. Invalid, what does this mean? invalid, valid. What's the? They don't repeat the header across the table.
If you log him as TN.
Correct.
Yeah.
Correct.
See, I have read it.
So system invalidated and admin validation override. So in this case, the system invalidated it, but the administrator overrode it, so it was a valid contact. But it says, the comment is, VK7GN logged me as VK4TW.
Oh.
So that's a typo on the keyboard.
That's a typo. Well and truly. VK7 to VK2 EFW, unique received call, should have been VK2 EFM, M, not W.
Yep.
So that was me putting it in wrong, or hearing it wrong. Go over to Richard. VK2 XIC, no matching call, no matching contact found. Invalid, but it was overridden. So VK2 XIC logged VK7ZB. Mixed the X.
Some of those contacts, I'll give you the tip, were right on the edge.
So same, exactly the same thing with 5ST. They logged you as VK7ZDX,
Yep.
not BX. VKTSR, not a valid call.
Yeah.
I think there should
That's
be
really
a
old.
number in there. VK6AUB, invalid, not a license call. VK72TTL should be VK2TTL, but it was made invalid.
Yep.
Murray, VK7ZMS, VK7FPCL, no matching contact found. But VK7PCL logged VK7MS, not ZMS.
I'll be out there to see Paul.
But it was made
Oh,
valid.
valid.
It was made valid.
But he would receive it as invalid.
Correct,
Ah, yeah.
because he logged it wrong,
Yep.
not you. VK7KC logged as VK7ZMK, not ZMS.
Mm-hmm.
Valid for you.
Sweet.
So now the invalids, VK7ZMS to VK7TA,
Should have been ZTA. That's a typo.
ZTA, should have been VK7FPCL, and it was FPLC.
Ah, that old chestnut.
Dyslexic.
Dyslexic. Yep.
VK, not that dyslexic's bad. Just put that on front.
Dyslexia.
Just the bottle will affront me. Yeah. Should be VK2IW. Should have been VK2YW.
So I only lost 3 points.
So have a look at the error log, because it's
Well, I think
you actually learn from
when we
that.
talked about it afterwards,
people-
I think I was 1 point behind it, and I ended up 2. So you must have.
Well and truly.
Yeah.
If people had used a few more phonetics, it would make it a lot easier. I heard FBOC being received as FTOC and FPOC.
Yep. Okay. And Anthony's now VK7LAG, so we'll get over that problem.
Just know
Do you
that you
have the
guys are
long
literally
list of
the
golden
RDSO
logs?
phone podium by height.
No.
Yes. Yeah. Thank you, Anthony, because he just put on the call. I noticed you guys are literally the RD single operator phone podium by height.
Roger that.
Yeah, roger that. Yeah, okay, that'll keep. So, any final comments about the RD from our studio audience, who is huge right at the moment? We've got a number in the studio. I'm not going to say how many.
The legal maximum.
I just like to say I think there was some reasons for the high scores this year, and I know my learning colleague to my left here will disagree with me because we've already had this conversation. But I think there was more people on air, and I think one of the reasons may have been no multi-multis, and all those people, all those big club stations where they have the club on 24 hours on a rotational basis.
Yep.
4 or
Multi-operators.
5 bands running all day, all night. they probably have 12 or 15 people to actually man that. And they were all unique calls this year because they were possibly working from home.
Yeah.
If they had equipment, that's the other point.
Well, that's right. So, look, it's just a theory, and I have no empirical data to back that up. But
Yes,
Could have also been the
as I said to
gathering.
you, Murray, I went looking for those call signs from previous multi groups and couldn't find enough of them to validate
I think we just drummed up a fair bit of interest, to be honest. In the
Certainly,
weeks coming
VK7.
up to it. You
Yeah,
know, like
true.
we were just sort of badgering everybody that came to the club, like, so you ready for the RD?
Just looking at the numbers, we really occupied 2 metre, 6, 270 and 1296.
23. Yeah.
I can't understand why Melbourne and the others didn't. The big
Well,
capitals
Well, and
Well,
trouble,
do the same
well, especially
thing.
Melbourne, because they were in lockdown.
Yeah.
Now, just taking up your point about the number of logs, the 2012 through to the sorry, Murray, taking up your point. The person who's talking should be on screen. 2012 to 2020. By far, 2020 is the highest number of logs with 259. And the closest we get is actually 2013 when there were 243.
it's also possible that people just had no plans to go anywhere or do anything
Well,
because you can't travel.
Correct.
So there's more people happy
But-
to be at home.
But that doesn't fit for Victoria because you would have expected a huge score from
Because they would have been
Victoria
home and not
because they were all
allowed to go out.
home.
And you would think
So-
the
or
density
should
there,
have
more
been.
people on 1296 and VHF.
I mean, I only say that because I myself was not going to participate this year because my dear wife had actually booked us on a cruise, which of
There you
course was so not happening.
Very poor planning.
So not happening.
So
Next year.
yeah, probably not.
Actually, I was meant to be in America, so there you go.
Yeah.
Yeah, we were supposed to
There
be
you go.
somewhere.
So perhaps
Look
a lot
what
of
happens.
people. Perhaps that's just why there's more people.
Yeah. No. Well, fantastic. So, any last comments? No.
Go VK7.
Go VK7.
2021.
Yep.
Bigger and better.
And can I just say, VK6, I think, put in a fantastic showing, and I suspect because you can see their scores
Trend upwards.
trend upwards in the VHF, UHF, and microwave area. I think they're starting to get
Themselves organised.
get themselves organised and
Yes.
realise how we're winning it.
Yes.
So
Yes.
it's going to be harder and harder for us to keep this.
Keep the traffic.
And we should also send a congratulations to VK2 EFM, who beat the record and still came fourth.
There you go.
Yes.
It looked also like Tassie did well at the 160 metre.
Oh yeah.
Oh, yeah.
Yeah. Because we
I'll get there next year.
okay.
You don't have to have much for it to
The other
work.
thing that I think we can't leave this topic without actually mentioning is the fact that the only reason we were able to get such huge scores is because everybody else was there to give us
To contact.
give us the contact. So,
Yep.
like a huge thank you to everybody in, especially for Southern VK7 for all the VHF, UHF.
Well, that's right.
Yeah, because the
12.96
bottom line is
Well,
some people got out of bed
it's not just
a
numbers,
wee
it's the
small
amount
hours
of
to come
time you
out.
spend on air as well, and that's where we really kicked it.
Yep.
And that's where that participation rate, that 56%, that's 56, is just blows everybody out of the water.
Yep.
That's just, and we had 20% of VK7 amateurs participating and 70% of them put in a log. Just got to be happy with that.
Gotta get the other
Chances of getting
30%.
20% of the amateur population in the one place at the one time's got to be a bit of a miracle, really.
Correct. Well and truly. So, fantastic. All right, cool.
Well,
Well done, everybody.
Thank you. So, thank you, Richard.
Thank you very much.
What we'll do is go on to, now Murray's got a very nice orange thing in front of us. What are we looking at? Yes, yeah.
put it over on the.
We'll put it over and we'll go to here. Zoom out. Oh, you want the rules? Yeah.
No, the results here.
The results? There we go. Thank you. Cool. No, go for it.
Sorry, I nearly gave away the wrong piece of paper.
my script.
Okay.
Oh no, that's just the back page. It's come off the staples.
So what we're looking at here is a bracket to mount. That's better. An FT-817/818 in your shack under a desk. That's the hole for the microphone.
That's the hole. You can see the hole for the microphone.
And if you turn it up the other way, you'll see there's holes in the bottom as well. And that's so that you can literally put the screwdriver up there to screw it into the bench. Because 817s don't have anything to mount them on. So
Who's that?
I don't know who that is, but that would be undoubtedly the call sign of the chap who designed the file that I downloaded from the internet. And
Thingiverse?
Possibly.
Now,
Possibly.
you put it in, and
Yeah.
I'll.
So it's just literally a sit there thing.
Cool.
So you can actually have that sitting in your shack and use it.
And they're very nice because you can see there's all your connectors
Yep.
that you can get to.
Yep. And so for those people who are using it not for a portable radio but for an IF for transverters
Cool.
in the shack,
Actually, you could put that into the case of the transverter, like 1.5
Oh.
AU
yep,
rack or something.
quite possibly.
Cool.
So
Excellent.
that was very kindly printed out by a colleague at work who recently acquired a 3D printer and was printing all sort of knickknacks. And I said, "Have you printed anything useful yet?" And he said, "Well, not really." He said, "Do you have something in mind?" I went, "Well, actually, yes. How about this?"
Have I got a deal
Now,
for you?
the thing is, when it prints out, it doesn't actually print out like this
No.
because, of course, you can't print above thin air. So,
So these brackets,
these
yeah.
top bits
These
has to have
top
supports have to be printed from the bottom up. Yeah, and so I don't know if we can put that on the.
Yes, we can.
Can probably turn the screen right up
Cool.
and zoom in on that. You'll see a picture I took of it. After, so on the left-hand side there, you can see the support structure still in place.
Oh.
Yep. And on the right side, you can see where I've just broken it out with the pliers.
So this is it broken out.
Yep.
And this is all the debris.
The debris, yes, and the pliers in the background.
Cool.
Yeah. So
I love it.
it just they broke out and a little bit of cleaning up with.
Oh no, and it comes out really clean. Actually, you wouldn't even know that it's.
Yeah, you've got there's a few bits and pieces you had to clean up with the.
A file or something.
Yeah, there's
or
another picture of it half broken out. So there is quite a bit of
breaking out.
excess.
Oh, bugger. Sorry, I just did something. You put it there.
There's quite a bit of excess material that's printed there just to hold those top supports up that has to be broken away.
Yeah. Okay.
So there is quite a bit of it, but it's got very honeycomb and it
just breaks it.
a fair amount of pressure, I have to say. I tried to cut it out with a standing knife and went, "Ooh, this is not going to work. Let me try something a bit more violent."
This is actually very nice. They are very nicely.
Oh yeah, it's a good design.
And you can see how it's all been built up. Like it's.
Well, that's the bottom. That was printed first.
But how they built up around the hole.
Well, yes, and what you've got in those holes, of course, is those holes are full as well. Because,
Yeah, okay.
Because the support structure has to sit, so there's stuff printed down through those holes as
Okay.
well.
Okay.
Yeah.
Cool.
So that's a very cool thing. Thank you, Phil. Much appreciate you printing that for me.
Definitely. Definitely.
And so now make its way into my shack.
Well, that's fantastic. Cool.
So I could just screw up. Probably not suitable for a car because there's nothing really to hold the thing from
Rattling around.
It literally is just a sit-it-in there device.
But it'd be relatively easy to make something that, like, even if you put foam or something,
Oh, look, you could probably do
Around
a
it.
design specifically for in a car if you really wanted to be in a car, but
Yeah.
um,
But that's not what it's designed for.
no, it's easy slide in,
I love it.
use it. And of course, once you get the microphone in there, it doesn't pull out anyway because
Yeah.
the microphone's right at the front of that hole.
Good point.
So that's secure.
I
Can't
love
accidentally drop it.
Thank you, Murray.
That's
Thank you very
White
much.
voice feeding on the
Now-
feedback.
Oh, yeah. Sorry. Or
Alright.
it'll get left there, and then you'll have to find it again.
No.
Yeah.
Like last week. For instance.
Now, can I get you to go and grab Rex for me?
Rex, absolutely.
Please.
I've got a beef, Justin.
Oh, here we go.
I had two errors according to the error log.
Right.
One was my fault. I misheard a VK2 call sign.
Okay.
But the other was the other person's fault for calling my call sign VK700. So I'm a bit cheesed off with that one.
Oh, right, okay. Oh, well, you know. Oh, well.
They lost the points, not me.
Yes. VK100. I love it.
VK700. Yeah.
I love it.
Oh, yeah.
I love it.
You go for it.
Very good. Very good indeed. Hello, Rex.
Hello, Justin.
Welcome to the studio. Guess what this is about?
I think I understand.
Now, what we've got, I'll outline. We've been doing some tests. Rex has been giving me a wonderfully stable 432 signal that I've been able to prove that I'm receiving very stably on my GPS locked receiver. We then went on to do some. I went on to do some carrier tests. This is probably the most dramatic. If we go to 222 and zoom out here, you can see what we're looking at here is. Where's my pointer? We're looking at time. These are 10-minute intervals going this way, and then we've got an audio frequency chart up here, which is, if you have a look, here's 700, 750, 800, 850, 900 hertz. So you can see here that and in fact that signal there is your signal, because that's at 700 hertz, or your 1000 kilohertz, 1000 hertz tone. So that's Rex's tone there, which is super stable. You can see at 700. I receive it at 700. But this signal here is the carrier from the 705 over, what is it? That's about 20 minutes. That's probably about an hour. That's about an hour. And you can see that we've got a drift from about 750 all the way through to about 900 on this peak, and then it drifts back to 750. So over time. So then we thought, I had a bit of a conversation with you after that around what is the shorter term stability of it, and we settled on Whisper, transmitting on Whisper. So Whisper is a 2-minute cycle, and you can see these are 2-minute intervals here, and you can see, and it's at 50% duty cycle, so it's transmitting 50% of the time. And you can see every time it starts, it drifts about 10 hertz from the start of the 2-minute period to the end, and then the second cycle, it is a bit more stable. It's about 5 hertz drift from the start to the end over that 2-minute cycle. The other concern here is this is 1520, which is what it's actually supposed to be. So
It's still within the 1400 to 1600 hertz range.
So this is decode. This well.
Not sure it'll decode.
Not sure it'll decode, but it's certainly within the
Decoding range.
The decoding range, well and truly, because that's the next test that we need to do.
Yeah.
However, the concern is that some of these aren't that bad. They're in the sort of the 5 to 10 hertz drift range, but some of these are quite a bit more than this. That would be 15 hertz. Another one up here, that would be 15 hertz, and you'll notice that maximum drift is after it has been actually off for 3 periods, so 6 minutes. So it has cooled down.
Yeah, and you get maximum drift.
And you get maximum drift after that, and that's supported by, you can see there's 3 periods here, there's 3 periods up here, and guess what? We've got the maximum drift as well. So we did,
which unfortunately, the way normally people work Whisper, there's always a long break before you transmit again,
Spot
so
on.
you're going to get maximum drift.
and again, this is backed up. This is another time later. So you can see there's a period here of two periods where it didn't transmit, and then you've got more drift. You've got 2 periods here, more drift, etc. So yeah, it's a whoops. So it's a bit of a concern.
I think what the conclusion is, it's not a transceiver for Whisper on 432.
Correct. That would probably be within the acceptable range for 2 meters.
It'll probably decode, but it won't give you the optimum signal to noise, because it'll be moving more than the 1.5 hertz that the bins are spaced.
Yeah. Okay. So now one of these, there is an article that's going into AR magazine. I showed you the cover earlier. That's the mock-up of the cover for next AR magazine. So which I showed earlier to the assembled throng. Just let me go back to. No, that's not right. Oh, that's better. So there's an article about the 705, and it matches the comparison that I did in the presentation the other day between the FT-818 and the 705. And also there is a comment in there around this, and one of these charts I actually have put into AR magazine. So I'll probably get hate mail out of that, but anyway, that's another story. But just this is to date what we have found with the 705, and it is quite susceptible to temperature drift. And Rex, what I did was take the battery out, which exposes the die-cast case on the back, and as soon as you take the battery out, the frequency drifts, because obviously there's a much greater cooling surface on the back that things are obviously connected to. I don't know how, but obviously connected to. So yeah, it's quite susceptible to temperature change at those VHF, UHF frequencies. So bit disappointing, especially given there's a GPS receiver in the actual transceiver.
Not really.
Well, there's a GPS receiver in the transceiver.
No, not for purpose of frequency.
No, correct.
Yeah.
Sorry,
it's just for purpose of finding position.
Correct. But they've got like they could just then go the one step further and put a PLL in there that actually is locked.
Yeah.
We're closer to where we need to be, just not quite there.
Yeah.
Just not quite there. But anyway, so and what I thought I would do is get an update on optical from you as to how the experimentation's going.
All right.
Oh. Oh, well, I'm prepared earlier.
Okay. Test that Richard and I were doing. You'll see that white line. What we've done there is we've actually reduced the bandwidth or the bin width to 800 microhertz.
Okay. 800 millionths of a hertz.
Yes.
Okay, yes.
And that reduces the amount of noise that you receive, you see.
Yes. Because you're listening to next to nothing.
Next to nothing. And that signal is with an LED running 50 milliwatts output at Richard's house.
Being received at your place.
Being received at my place on an absolutely non-line of sight path over Mount Direction.
Amazing.
Yeah.
Absolutely amazing.
So
these are hour segments?
Yes, that's left it
Yeah.
running all night.
Okay. So this is each hour. But I tell you what, that's a decent signal. That's a...
It's actually about 12 dB above the noise.
Okay.
Admittedly, we did it the next night, and conditions were a bit different. You could
Yeah,
still
okay.
see it's there, but it was coming and going, and even to do that, we had to go up to 80 milliwatts.
I tell you what, there's a lot of noise in here too. That's not here. Or is that?
That's because this is so strong
Oh, okay.
that I didn't have to turn the gain up. Whereas for that, to
Right.
see that at all,
Yeah.
I had
So
to
it picks
turn
up
the gain
absolutely
up,
everything.
and so the noise comes up as well.
Wow. And that's slightly stronger too, at
Yes.
80 milliwatts.
80 milliwatts.
Okay.
But perhaps some background of why we're doing this again after
A long time.
10 years since we've done optical stuff is that Joe Taylor has up to now he's wanted to keep this a bit quiet, but he's about to release it, so
Okay.
I'm sure he doesn't mind me talking about it.
We got a stop press at the DATV night.
So probably within the next week,
Okay.
a new program will be released on the WSJTX modes,
Okay.
and it has two basic modes. One is called FST4, and then it has options of how long you transmit, from 15 seconds up to 1800 seconds for a message.
Okay.
And the other is FST4W,
Okay.
which is a whisper replacement.
Okay.
And it actually goes from 120 seconds, which is the normal whisper time, up to 1800 seconds.
Okay.
And Richard and I have been using that, and we've been getting decodes at minus 45 dB.
Okay.
Admittedly, taking half an hour to
do that.
to do that.
That's at 1800 seconds, I assume.
That's
is it?
right. That's what
Okay.
half an hour is.
Yeah.
1800
Yeah.
seconds.
Yep.
The program has been being beta tested, and I was fortunate to be invited to be part of that.
Okay.
And I decided to test it at optical because I don't have. It's really designed for LF and MF, which I'm not set up for. But there has been signals between VK4 and
Yep. Roger.
North America
Yep. YB.
using it, and I think we're very close to. There might be one more beta test version come out.
Okay.
It works extremely well on optical, because effectively optical is AM, so frequency stability is not an issue, even though you're actually on 474
Terahertz.
terahertz.
Yes.
but you can actually work in bandwidths of 800 microhertz at 474 terahertz.
That is outrageous.
So I hope within the next week it will be.
A product that everybody can use.
That's right.
Cool.
So,
Cool. Well, I look forward to that, definitely.
because you're on HF and MF and LF.
MF and LF, and that means you can probably work the world. Because we get between us and the US every so often now.
Right.
So we'll the extension of the range will be phenomenal. That will mean I need to put my antenna back up again, because that wind we had, my antenna's on the ground.
what made we have been
Whisper? No, it was Whisper.
Whisper.
That
Yeah.
was Whisper before.
Well, Whisper. So this potentially gives you about another 15 dB over Whisper.
Yeah. So fantastic. So because it's only in really good conditions that I decode the US. I decode the guy in Hawaii more often than not.
Right.
But mainland US, very rarely.
Oh, well,
So there you go.
something to look forward to.
Definitely. Oh,
Okay.
fantastic. Thank you,
All
Rex.
right, no worries.
Thank you. We look forward to.
I should mention, with this light stuff, the maximum distance we've got is 153 kilometres
Between?
between Mount Wellington and White Hills,
Cool.
and we did that in the expectation that Richard's home location has a very poor takeoff to the north,
To the north, yeah, okay.
and surprisingly, when Richard came home, we tried it again and the signals were better.
That sounds familiar. Right, okay.
And that for that 153 kilometre path, we're actually getting signals at minus 13 dB.
Wow. They're strong.
Yes.
That's strong.
And looks
Okay.
like it was scattering off the ice crystals of cirrus clouds.
Okay,
When we
okay.
looked at the radiosonde data, and
Yep.
we could see
So high altitude sort of stuff.
really high, 11,000 metres.
Wow, okay. Okay.
So there's still a lot to learn in this light stuff.
Well and truly.
You have to go back to it.
Uh,
Okay.
Thanks, Rex.
Okay. See ya.
We look forward to the next instalment.
Yes.
Oh, very good. Very good indeed. Okay, what we might do here is I'll just do a little bit of a reset. Okay. Now, what I've got next is the next instalment of the NanoVNA. What I'll do is just a quick bit of setup here, and our subject tonight is a mystery filter. So it looks because of the I have to get from a UHF connector to an SMA, and I don't have a UHF to SMA, so I've got to do a transition through a BNC. But anyway, so it looks quite steampunk, really. But this particular filter, I think I picked up at a Hamfest, or might be a Deceased Estate, or something along those lines. And of course, it had absolutely no label on it, and it's soldered up. So even if you undo these the holding screws on the UHF connectors, you're not going to find much out. The only thing that is evident is if you tap it, it's got some sort of coil in it, because you can actually hear it. So unknown filter of some description. So I thought, well, hey, I've got this wonderful NanoVNA device that can test things like this and actually tell us what this actually is. So what I thought I'd do is go through that process on the screen. On the screen in close up, which, alright, let's zoom in here a little bit to our NanoVNA, and I reckon I can get that a bit, there we go. So, now, from our last episode with the NanoVNA, I very quickly learnt that the very first thing you do when you switch on your NanoVNA is do a screen calibration, because the calibration on the screen seems to, and we go down to config. This is why you do the screen calibration. There we go, that's better. So go to config, touch calibration, and you can see touch the upper left and then touch the lower right, and we are back where we need to be. So from our learnings last time when we did the calibration and why we do a calibration and when we do a calibration, so we need to set up the traces, we need to set up the frequencies, we then go through a calibrate process, so we'll go through all of that. Now the traces, you can see up on the top of the screen we've currently got channel 0. Now channel 0 is the S11 input of the 2-port device. This is the receiving port, and then S22, which is 21, which is the transmitting ports, or channel 1 is the transmission port. So you can see what the traces are set up by default, which is channel 0 is the log magnitude of the reflection coefficient for this input, and then the also on this particular input is the Smith chart. So the yellow is the log magnitude and the green is the Smith chart. Over here the channel 1, so this is the transmission port, is set up for the log magnitude of the reflection coefficient, and also for whatever reason it defaults to, it's the log magnitude of it as well in a different color. So it's actually receiving exactly the same thing. So the one trace that we need to change here, we need to go back, and we go to display and trace and the last trace. So you can see, we can turn that off and you can see it disappears from up here, or we can turn it on and then it's highlighted. So the next thing we do is we specify what we want that trace to be. So we go back and we go to format and we say SWR. So what we're going to do is the SWR of this particular port, which will be displayed. So we've set up the traces. We now need to go through the calibration process. Now, given we're going to, and I'll zoom out here a little bit, given we're going to be connecting these up using these particular SMA cables, we connect up the SMA cables because part of the calibration is around taking into account these connections and the phase differences, etc., of these cables. So there we go, there's the barrel. So we'll go through a calibration process. So back in here, go back, oh come on, we'll go back. I've got the same problem I had last time. Come on, why aren't we going backwards? Why aren't we going back? Oh, there we go. Okay, so we go back and we go back and we go to cal and calibrate. So the very first one that we want to calibrate, and it takes you through the sequence here. The first three, the open, short and the load, if you have a reflection type, so you're only using channel 0, the receiving port. You set that up for open, short and load. If you're doing the through test, which we are with a filter, you need to go through the open, short, load, isolation and through. So the very first one that we need to calibrate on is the open. So let's connect a barrel and the open. So this is the one that has no pin in the middle. And why do we do this? Because the measurement plane is right here. We've moved it out so that it takes into account these cables, and this is where the measurement plane is. So we'll do the open check, and the next one it's telling us to do is the short. So we'll unscrew that one. Oh, and the barrel comes out, doesn't it? This is the short. We'll connect that up to the S11 port, and we'll do the short, and it's telling us the next one is the load. So we unscrew that and we put on the 50 ohm load, and there we go. Oh, hang on. So there's the 50 ohm load. We go load, and the next one is the isolation. Now, the isolation, what we need to do is to do this isolation test on a through arrangement. We put the load on the transmission port and do the test. And then the last test is the through port, through test. So this is taking into account the whole lot of cables. So we just put the barrel between the two of them, which is where the device under test would go. And we click the through. And we're done. And we can save that. We'll save that to number 4. So we've actually now the probably the thing I didn't do here was set up the frequency, which we have to do actually before we do the calibration. So we'll assume that we've done that just for speed. We'll set up the back. We'll go to stimulus and we'll set up the frequency. Now what we want to do is, I think this is, given it's got UHF connectors on it, it's probably a HF type of filter. So we'll go to 100 kilohertz and stop on, I don't know, 100 megahertz. We'll try that. So we've set up the frequency. Now theoretically we should be doing the calibration again because we've changed the frequency, but I won't do that in this particular case. But what I'll now do, we've done the trace, we've done the frequency, we've done our pretend calibration. We'll go and connect up our filter and see what it's telling us. These cables are only just long enough. So, we'll zoom in here because I want to show you what this is actually telling us. So, now the blue trace is the key one here. What we're talking about is over here is 100 kilohertz and over here is 100 megahertz. So let's move our cursor on that blue trace, and you can see I haven't done the calibration, so this is all over the place here. So let's go up to where that, so at the top of where it starts to disappear is about 35 megahertz. So that's telling me that this filter drops off at around about 30 odd megahertz and drops down quite considerably, and we'll measure that in a minute, but drops down quite considerably and quite fast. So I'm looking at we're looking at a low pass filter. So it's basically letting everything through above 30 megs, So it is a HF. I suggest it's a HF, a low pass filter. Reasonable guess. So if we look at 28 megs, say 10 meters, so the second harmonic and third harmonic would be 56 megs and then 84 megs. So if we then go, move our cursor to around about as close as we can get to 54 megs, that's the second harmonic, and this is all over the place. So if we read off, this is the log magnitude of the reflection coefficient in this blue one. If we read off, it's actually telling us, this is because I haven't calibrated it, it's actually telling us around minus 34 dB for the second harmonic, and then if we go further out to the 84, around about there, I'd expect it to be a little bit lower than that, which is about the same. So I'd expect it to be a little bit more than that, but given we haven't actually calibrated it at this frequency, that's why it's jumping around. So it's at least 30, probably 30, 38, 40 dB down at the second and third harmonic. So we're looking at a low pass filter. The bottom line is we're looking at a low pass filter here. And the Smith chart is telling you that the complex impedance plotted on the Smith chart, and then the other the other important one is we set up the second trace for the channel 1, which is that purple trace. You can see it comes along and then drops right down at about 30 odd megs, is the SWR. The SWR, did we set it up for the SWR? Yes, we did. Ooh, hang on. We really do need to do a quick calibration on this, don't we? Just let me do the calibration, because it's all over the place. So just bear with me. Back, calibrate, open. Okay. So I'll just very, very quickly do this calibration. That's the open. Okay, cool. Open. Oh, come on. Zoom out a bit here so you can actually see what I'm doing. Open. Now we do the short. At this frequency. So we'll do the short. Okay. We'll do the load. We'll do the isolation. And we'll do the through. And we'll try this again, and I suspect we'll find that we'll get a much deeper and load done. Save that to 4, and we'll connect up to our filter, and we'll see make sure that all of those are done up. Right, okay. So, that's better. Amazing what calibration makes, difference a calibration makes, because it's now stable. So, let's go back to, and we'll put our cursor right at about that point there, that's the same, that's about 33 megs. If we go to the second harmonic, which is the 56, 56 is almost to the bottom of this curve, which is minus 66 dB. That's a bit better. If your filter's only giving you 30 dB, you probably need to redesign your filter. And the thing is, the third harmonic here actually will give... Oh, hang on. We don't want to do that. We don't want to do that. The third harmonic here at 84 is actually down at the same sort of level. So you're still at that minus 60 odd dB. So you wouldn't be unhappy with that. So anyway, we've worked out it's more than likely a HF low pass filter. It's a reasonably small, physically low pass filter, so you're probably looking at, I don't know, you probably wouldn't want to put more than probably a couple of 100 watts through it, if that. The kilowatt low pass filters are quite a bit bigger, but it's certainly a HF low pass filter that we've been able to establish that by using the going through the process with the NanoVNA. So it's another way of using your NanoVNA to actually sweep a filter, an unknown filter, and try and work out what the filter's all about. Yeah, next week I'll probably try and do maybe a time domain reflectometry test, which you can do with these to give you a measurement of how long your piece of coax is, or how, what condition your coax is in, or something like that, because that's really handy as well. And you can do that with coax that's in situ, which is a bit of a nice feature to actually do. So anyway, that's our NanoVNA for, let's go back to, alright, cool. So our videos for tonight, that's a good point. Where's my page gone? Oh, here it is. Here it is. So our videos for our RF viewers, our videos, we've got Whiskey 2 Alpha Echo Whiskey, which is, I've referred to his videos before. He's done a whole series on the NanoVNA, and literally doing very similar to what I just did then. So he's worth a bit of a look. He is measuring. He knows it's a low pass filter, so he measures it, but he goes through the same process. So that's fantastic. The next one is Ham Radio DX, which is the setting up WSJT on an IC705. So from Hayden. Bit of a 705 theme here. Ham Radio 2.0, why you should not buy an IC705. So that was an interesting video I thought I'd throw in here. And then Ham Radio Crash Course is setting up a Raspberry Pi to work with GPS on the IC705 as a bit of a portable arrangement with a 705 and a Raspberry Pi going portable. So they're the videos for tonight. So I'll get them underway. What I will do though is I'll take just do a bit of a call out for anybody who is wanting to make any comments or call in for tonight's DATV night. I'll just go out on R2 first. This is VK7 OTC, the club station of the Radio and Electronics Association. Just putting the call out for any comments on our DATV presentation tonight. Over. Good evening, Ron. Go ahead.
Good evening, Justin. Very interesting presentation tonight. Very interesting about the VNA, but I don't think I'll buy one. Thanks again. Cheers.
Oh, come on, Ron. They're only $120, and you get a VNA in a cigarette case.
But you got to operate the stupid thing. Cheers.
Roger. Okay. There is plenty of material out there in YouTube land on NanoVNAs, but I understand. Thanks, Ron. Thanks for calling in. Any further call-ins tonight? Go ahead. No, we'll go out on 3807. This is VK7 OTC. Just putting the call out for any comments or questions from our for our DATV night. Over. Tell you what, you really get the digital interference on that on that monitor when you transmit. Okay, final call. Any comments or questions for this evening's DATV Experimenters Night? This is VK7 OTC. No? Okay, that's good. And okay, thanks from Anthony. Hope you got something from that, Anthony. A bit more about the NanoVNA and what you can use it for. So yeah, very impressive little device. Given that VNAs used to be things that cost tens or not, if not hundreds of thousands of dollars, you can now get it in a box that at least helps you experiment and do bits and pieces with your antennas or filters or any RF device, I suppose. So yeah. So I'll bid you farewell. Thank you for watching. For those people out there in YouTube land and streaming land, and we'll head to our videos for our RF viewers, and we get back underway next week, same time and same channels and same streams. So this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night and 73.